So then if I take another coffee, and that coffee is more dense, which what I mean by that is every seed weighs more. So whenever you weigh out your 0.8 kilos, you're actually weighing out less coffee. You'll see in the bucket that you're weighing it, it'll be stunted. It will be a little less. There'll be less material. So what that means is two things. The first thing is in your drum, this is your drum. Your drum has these things that fly off of it that toss coffee about, right? As your drum is rotating, let's say it's rotating this way, your coffee is collecting, and your coffee will start collecting. Actually, it collects right up here, okay? But it's also tossing about, tossing about, tossing about. If I have less coffee in that drum, the mass of that coffee is going to be more diffuse in that space. So the dense coffee is going to come in contact with metal and other coffee seeds less often, okay? That also means that my coffee seed is going to dry out a little bit more quickly on the outside because it's exposed to more air that's taking that moisture off of the coffee. So what ends up happening also along with that, where my probe is, wherever that probe is in that drum, it's getting hit by less coffee. So it's showing that my coffee is actually having a smaller effect on this number, okay? So if it's having a smaller effect, that means that it's going to change the way that that temperature is corresponding to my turnaround, okay? So it may show you that you are turning around more quickly or more slowly depending on the density of the coffee that you're putting in there. Because the mass of 0.8 kilos could be any number of beans. It could be 2 million beans, it could be 1.5 million beans, it just all depends on your roaster. So you want to think about how these things correspond together. So if you are changing your coffee, it is very important for you to understand where your turnaround needs to be for that particular coffee. And I can't tell you, you need to be at 175 degrees Fahrenheit on your drum for this particular coffee, because every coffee is going to have its own turnaround temperature. So let's simplify this. To simplify this and not get caught up in the weeds of all of this, it's very important that you keep track of your roasts, okay? That you pay attention to your start temp, that you pay attention to your beans temperature, your coffee's temperature, that you try to keep track of a very thoughtful and consistent batch size for whatever coffees that you're using, and then pay attention to where that coffee naturally wants to turn around at a general drop temperature. So instead of messing with your coffee and saying, well, I'm going to do 60% batch today, and I think that I need to then lower my charge down to 395 and then try to find out where my turnaround temperature was whenever I had a point, or an 80% batch at 400, that's all out the window. Even though you're turning around at the same temperature by pulling all those pulleys and levers and making that happen, that doesn't necessarily mean that a minute, 2 minutes, 3 minutes down the road, you're going to be on the same path. Okay? So keep these things as consistent as you can until you fully understand how each coffee is turning around. Okay? If your coffee is turning around more quickly, then your coffee is probably a little bit less dense. It's going to take on the heat more quickly, and it's going to move through the roast a lot more quickly. If your coffee is turning around a little bit later, then your coffee is probably a little bit more dense. It's not taking on the heat as quickly, and that's okay. A lower density coffee needs a little bit more time to absorb that heat, both because of the structure of the coffee and because of the nature of how that coffee is in the drum, okay? So your more dense coffee is going to pull harder against this, and it's going to drop down further away. This distance is not going to be very significant, but it still matters. And why does it matter? Well, if first crack happens at a particular temperature, which it does, then if this is 5 degrees lower, then it's going to take you that amount of time to get to first crack. It's going to be a longer roast automatically, and you want to make sure that you're not rushing it as you're getting it out of your turnaround. So the way that I look at this, and you've heard this analogy probably before, is this is kind of like a launching pad to the speed that your roast is then going to move forward. And so if your coffee is coming down on this launching pad too hard, then it's not going to be able to pull up out of that turnaround. If your coffee is coming down and getting stopped before that launching pad, it's going to just blast off, and it's going to take off very quickly. Okay? Any questions?
Just a quick summary.
Yep.
We can't emphasize enough. Please be consistent until you learn your roaster. Time after time after time, use the same charge size. Joe's talked about most of the roasters out there. Sweet spot about 75 to 80%. For those of you that are on North, your full charge size should be 1 kilo. It's not down in the 80% range. It is a full kilo or full 500 grams. That's one thing. Joe, would you define density? And you say one has low density and one has high density. What does the density of a coffee mean?
It's your mass over volume. So you can think about it as being, if you have 2 balloons and they're both the exact same size, that is your mass. If one of them is filled with water, that's your density. It's a lot more dense. There's a lot less space in the balloon between molecules, okay?
And in the coffee cell, what creates that density?
The coffee cell should be more dense based on all of the compounds that coffee has stored into itself. So it's not water. So I know I use the balloon analogy with water, but in a coffee, you could have a coffee that is 11% moisture. They could be the exact same seed size, but one may weigh more than the other because it has more densely compact carbohydrates, you know, all of the other sugars, all of the other things that go into that coffee seed that you're going to turn into flavor. The moisture is kind of insignificant as it pertains to the density of the coffee. Moisture is kind of static. So the actual compounds that you're going to be converting into flavor are what build up the density of the coffee.
And if I remember correctly what you said, denser beans, where that cell structure is tighter, are going to turn around at a lower point than coffees with a lower density.
That's right.
Okay.
And if you think about that in terms of that coffee starting at 75 degrees or your room temperature, then your roaster has to do more work to get that dense coffee to move forward through its heating process. And again, that's because it's more diffuse in that space. And because those denser seeds need more energy in order to get to the same place. If you think about this in terms of movement, if you have a car that weighs a lot and another car that doesn't weigh a lot and they have the exact same engine, the same amount of fuel moving them, that very heavy car will move much more slowly with the same amount of energy applied. So again, you're starting here with your coffee. So if you have a very high dense coffee, it's going to take a lot more energy to move it forward. Now, automatically that makes me think from like a physics standpoint, then that means I should be at 410. Or that means I should be hitting my throttle harder. Instead of being at 4 inches of gas, I need to be at 5 inches of gas to get that moving. Well, if you do that, you're going to scorch your denser coffee. It's going to burn the outside without that heat getting a chance to penetrate. So that's why I say, no matter the density, while you're learning the process and learning your machine and learning that coffee, try to start with a consistent temperature here, a consistent temperature here, and a consistent weight. And it may be the case that eventually you get to a place where instead of using a weight in, you're using a mass in, so like a particular size on a graduated cylinder of some sort. That could be the case. But the geekier you get with all of these things, and the more you start going down rabbit holes, the more likely you are going to miss the forest for the trees, and you're going to get into the weeds. And if you just pull back and keep this stuff as simple as possible, and then see how your coffee roaster responds, and then you respond to that information in a clear, level-headed way, you're going to get a much better result out of your roaster.
Joe, you've got a data point here and turning point. How do you use that? Okay, it's a piece of information. Now that I have that piece of information, what do I do with it?
So all of the data that you're collecting should result in one piece of data that is the most important data, okay? And that is does it taste good? Does it make you happy? At the end of the roast, is it an aesthetically pleasing roast? So all of this stuff is pointing to this. And how do you know whether or not all of this stuff matters is by tasting it, by sharing it with friends, by sharing it with coworkers if you're in a professional setting. Taste, 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 okay? So then when you're starting with all of this, and as we're going through the next segments of our classes over the coming months, and we're covering more and more of this chart, then when you get to this, and unfortunately it's a little bit more like this, then you can go back down the chart and you can find exactly the point where something went wrong. But if I've changed this, if I've changed this, if I've changed this, if I've changed airflow, if I've changed gas, if I've made all of these adjustments, then how do I know where exactly I need to make a change to fix anything? I don't. So you have to start with something that's very cut and dry, very simplistic. And even though this looks very simplistic, starting in this way, this is actually very complex, and it's setting you up for success. It's just like you're building a house. And if you look at a blueprint for building a house, the basements of all of these different houses look very simplistic. But they're simplistic because they're tried and true, and we know that the structure that we can build on top of that can diversify in all different ways. But if our foundation, which is the beginning part of that roast and the turnaround, if that is in place, then we can move forward and start getting a little bit more creative with the roast a little further on.